Take a deep breath in, letting your lungs fill with the quiet night air, and as you exhale, allow your body to settle deeply into the comfort of your bed. Let go of the day. For tonight, we are drifting outward, embarking on a serene journey to the very heart of our home, the galactic core of the Milky Way. We begin our voyage by untethering from the Earth, slipping gently through the solar system, and setting our course for a destination that lies approximately 26,000 light-years away. The core is nestled securely in the direction of the constellation Sagittarius, a silent, glowing beacon anchoring the slow rotation of the galaxy. As you feel the comforting weightlessness of deep space wrap around you like a heavy, velvet blanket, you might look ahead and notice that the center of the galaxy is not blindingly bright to our human eyes. And this is because the galactic center is shrouded by incredibly thick, cold lanes of interstellar dust. This cosmic dust is so dense that it absorbs and scatters the light of the stars behind it. In fact, it takes roughly 1 trillion visible light photons, leaving the galactic center for just a single one, to make it through the dust and reach our eyes on Earth. Because of this beautifully dark veil, the core remains a hidden sanctuary, a secret room tucked away in the vast mansion of the cosmos. To pierce this velvet fog, we must change how we see. We must tune our senses to infrared, radio, and X-ray wavelengths, just as astronomers do when using vast observatories to peer through the cosmic clouds. As we shift our vision to the infrared, the dark dust suddenly becomes transparent, revealing a radiant, majestic metropolis of light. We drift inward along the Orion Spur, drawn by a gentle, invisible tide toward the Milky Way's central bar. Our galaxy is a barred spiral, and this central bar of stars is a colossal, elongated structure extending roughly 27,000 light-years across. It serves as a gentle, rotating funnel, an ancient cosmic conveyor belt that channels interstellar gas and dust directly from the spiral arms inward to feed the galactic core. Floating along this stream, you can feel the slow, rhythmic clockwork of the universe, everything moving with deliberate, unhurried purpose. As we reach the inner regions, the very texture of space begins to change. Out here in our solar neighborhood, stars are lonely wanderers, separated by light-years of empty space. But as we enter the central parsec of the galaxy, a region just over 3 light-years wide, we find a spectacular gathering. There are over 1 million stars packed together in this nuclear star cluster, forming a brilliant, glowing swarm. If our Earth orbited a star in this dense cluster, the concept of a dark night would not exist. The night sky would be 1,000,000 times brighter than our own, bathed in a perpetual, golden twilight. The starlight would be so thick, it would feel almost tangible, casting a soft, multi-directional glow that erases all harsh shadows, leaving only a warm, luminous embrace. Drifting closer still to the absolute center, we pass through a sprawling giant molecular cloud known to astronomers as Sagittarius B2. Here, the chemistry of the cosmos reveals an unexpected sweetness. Within the freezing, frictionless vacuum of this gas cloud, there are billions of liters of complex organic molecules, including a specific compound called ethyl formate. Ethyl formate is the exact chemical compound that gives raspberries their distinct flavor, and it carries the faint, sweet scent of rum. Imagine the aroma of cosmic raspberries drifting through the quiet dark, a deeply grounding reminder that the familiar building blocks of nature, the very atoms that make up the fruits and scents of Earth, are born and suspended in the deepest, most alien reaches of the unknown. You are deeply connected to this place, You are made of the same stardust. As we press further inward, you might feel a subtle, sweeping alignment, a cosmic tide pulling gently at the fabric of space. The galactic center is governed by immense magnetic fields, estimated to be 10 to 100 times stronger than those in the outer spiral arms, where our sun resides. These magnetic fields act like invisible silk threads, weaving and organizing the flowing gas into elegant spiraling filaments that stretch for hundreds of light years. These threads of magnetism weave through vast clouds of ionized gas that have been heated to millions of degrees Celsius by ancient stellar winds and supernovae. You might wonder if such heat would be overwhelming, but space operates on a beautifully counterintuitive logic. Because this superheated gas is unimaginably diffuse, with atoms spread so far apart, if you were to float within it, it would feel like nothing at all. There is not enough matter to transfer the heat to you. It is a comforting void, a place of pure, the harmless thermal energy, where you remain perfectly safe, perfectly cool, and perfectly at peace. Gliding gracefully through this diffuse warmth, we pass Sagittarius A East, a sprawling, wispy remnant of an ancient supernova explosion. Astronomers estimate this ghostly, expanding shell of gas is between 35,000 and 100,000 years old. As it expands, its slow, silent shock waves act as a cosmic plow, gently compressing nearby clouds of dust to spark the birth of entirely new stars. It is the eternal rhythm of the cosmos. From the quiet end of one star comes the soft, glowing beginning of another. Looking far above and below the flat plane of the galaxy, we can sense the majestic presence of the Fermi bubbles. Discovered in the year 2010 by the Fermi Gamma Ray Space Telescope, these are two gargantuan, glowing lobes of plasma emitting high-energy gamma rays. They balloon outward, extending a staggering 25,000 light-years above and 25,000 light-years below the galactic center. They are the remnants of an ancient feast exhaled by the core in a slow cosmic breath millions of years ago. To witness them is to watch the galaxy breathing, rising and falling in deep geologic time. And finally, we arrive at the quiet gravitational maestro orchestrating this entire galactic symphony, the very center, Sagittarius A star. Discovered in 1974 by astronomers Bruce Balick and Robert Brown using the Green Bank radio interferometer. This is the gravitational anchor of our home galaxy, Sagittarius. A star is a supermassive black hole, a region where gravity is so profoundly intense that the fabric of space and time curves completely in on itself, and not even light can escape its gentle but firm grasp. It holds a staggering mass equal to 4.1 million times the mass of our own sun. Yet, despite this incomprehensible weight, its physical presence is surprisingly, almost comfortingly, compact. The event horizon, the boundary of no return, spans roughly 26 million kilometers across. To put that into perspective, if you were to place this supermassive black hole at the center of our solar system, it would easily fit within the orbit of Mercury. Millions of suns packed into a space smaller than the distance to our innermost planet. It is a pocket of infinite density, a quiet, dark eye in the center of the glittering storm. We know exactly what this silent shadow looks like. In May of 2022, the Event Horizon Telescope collaboration released the very first image of Sagittarius A star. They revealed a glowing, donut-shaped ring of superheated gas, shining in soft orange and red radio frequencies, surrounding a perfectly calm, pitch-black center, the shadow of the black hole. It looks like a warm hearth fire in the darkest night of winter, radiating a quiet, ancient power. Around this silent, heavy shadow dances a tightly bound, exclusive group of stars known as the S stars. They move with fluid, hypnotic grace, tracing intricate elliptical orbits dictated by the massive gravity of the black hole. Because the black hole is so massive, these stars do not fall in. They simply swing around it in a perpetual, mathematically perfect waltz. One of these stars, named S2, is a brilliant blue giant that completes a full orbit around Sagittarius A star every 16 years. In the grand scale of the cosmos, a 16-year orbit is a mere blink of an eye, a frantic, beautiful pendulum swinging in the dark. As S2 swings through the pericenter, the closest point of its orbit to the black hole, it reaches a staggering velocity of over 7,600 kilometers per second. This means the star is moving at nearly 2.5% the speed of light. Imagine watching it swing past, a brilliant sapphire tracing an arc of light through the dark, guided safely by the invisible hand of gravity. It is the ultimate expression of cosmic clockwork, reliable, predictable, and deeply soothing. There is no chaos here, only the strict, beautiful adherence to the laws of physics. Despite this rapid, mesmerizing dance at the very edge of the abyss, the broader nuclear star cluster surrounding the core is predominantly a place of ancient, unwavering stability. Among the millions of stars glowing in this twilight realm, many are red-hued elders. These stars are over 10 billion years old, having formed when the galaxy itself was just beginning to take shape. They have burned slowly and steadily for eons, silent witnesses to nearly the entire history of the universe. As we drift among these ancient, steady stars, you can feel the deep, resonant calm of the Galactic Core. It is a place of extremes, yet profoundly peaceful. A place where gravity holds everything in a delicate, enduring embrace. Allow yourself to rest here in this comforting void, suspended in the gentle light of a million suns, as we prepare to sink even deeper into the mechanics of this beautiful turning wheel. We linger here among the ancient, ruby-hued elders of the inner galaxy, surrounded by the quiet hum of a million suns. Suspended in this weightless sanctuary, it is deeply grounding to look back across the 26,000 light-years of space and trace the long, quiet lineage of how human minds first reached out to understand this place. For thousands of years, our ancestors looked up from the surface of Earth and saw only a pale, milky band painted across the night sky. The ancient Greeks called it the Galaxias Kyklos, translating beautifully to the Milky Circle. To them, it was a celestial river of light, an ethereal mist resting far above the clouds. They could not know they were looking edge-on into the sprawling disk of our own galactic home. The true nature of that Milky River remained a mystery until the winter of 1610, when Galileo Galilei pointed his newly crafted telescope toward the heavens. Through those early, imperfect glass lenses, he made a startling observation. He realized that the glowing band was not a continuous cloud of mist, but was instead composed of countless individual stars, clustered together so tightly that the naked eye blurred their light into a single, glowing stream. This realization fundamentally shifted our place in the cosmos, revealing that the night sky possessed a depth and complexity far beyond human intuition. Consider the ambitious effort of astronomer William Herschel, who, in 1785, attempted to map the entire shape of the Milky Way simply by counting the stars he could see in different directions. His resulting map depicted a flattened, irregular disk of stars, but crucially, he placed our solar system very close to the center. Herschel was entirely unaware of the dense clouds of interstellar dust blocking his view. Because the dust dimmed the light evenly in all directions along the galactic plane, it created a perfect illusion. It appeared as though Earth was resting in the middle of a small, finite island of stars. Astronomers now refer to this heavily obscured region along the galactic equator as the zone of avoidance. This thick band of dust and gas acts like a heavy, velvet theater curtain, physically blocking our view of the universe beyond. In fact, this zone obscures roughly 20% of the entire extragalactic sky. For generations, the true center of our galaxy remained perfectly hidden behind this dark, dusty curtain, keeping its heavy, spinning secrets locked away in the quiet dark. The illusion of our central placement persisted until the year 1918, when an astronomer named Harlow Shapley embarked on a meticulous study of globular clusters. These are dense, spherical collections of hundreds of thousands of ancient stars that orbit the outer halo of the Milky Way. Shapley mapped the exact three-dimensional positions of 69 different globular clusters. He discovered that they were not distributed evenly around our solar system, but were instead heavily concentrated in a singular direction, toward the constellation of Sagittarius. To measure the vast distances to these clusters, Shapley relied on a specific type of celestial object known as an RR, Lyrae variable star. These remarkable stars function as standard candles for astronomers because they pulsate with a strict, predictable rhythm. As they physically expand and contract, their brightness rises and falls like a slow, steady heartbeat in the dark. By measuring the rhythm of these pulsing stars, Shapley realized the terrifying and beautiful truth. The center of the galaxy was unimaginably far away. Earth was not the focal point of the Milky Way, but merely a quiet outpost located in the quiet suburbs of a sprawling cosmic empire. Notice how the pursuit of knowledge often requires us to develop entirely new ways of sensing the world. Because optical light could not penetrate the thick dust of the zone of avoidance, humanity had to learn to listen to the unseen spectrum. In August of 1931, a Bell Telephone Laboratories engineer named Karl Jansky was tasked with investigating sources of static interference that might disrupt transatlantic radio telephone service. He built a large directional antenna out of brass pipe and wooden beams. He's setting it on 4 Ford Model T tires so it could slowly rotate and scan the sky. Over months of patient observation, Jansky isolated a steady, unexplained hiss of radio static. By 1933, he successfully tracked the source of this persistent hum. It was not coming from Earth, nor from the Sun, but was radiating from the exact coordinates of the galactic center in Sagittarius. The specific signal he recorded was vibrating at exactly 20.5 megahertz, which corresponds to a radio wavelength of 14.6 meters. Without even meaning to, Karl Jansky had become the very first human being to detect radio waves originating from beyond our solar system, fundamentally inventing the field of radio astronomy and opening a brand new sensory window into the unseen universe. Picture the slow, then steady progression of our mechanical eyes, stretching further into the invisible spectrum. Decades later, in 1968, astronomers Eric Becklin and Jerry Neugebauer successfully peered through the galactic dust using infrared light. To accomplish this, they utilized the massive 119-inch telescope at the Mount Wilson Observatory in California. Because infrared sensors measure minute traces of heat, their equipment had to be meticulously cooled using liquid nitrogen. By chilling their detector to hundreds of degrees below zero, They prevented the ambient heat of the telescope itself from blinding their view. Through this extreme cold, they successfully mapped the warm, glowing dust of the galactic core for the very first time. They revealed a bright, dense, and energetic nucleus that had been quietly burning behind the curtain for billions of years, entirely unseen by human eyes until that exact moment. Deep within this newly revealed landscape, nestled just outside the supermassive black hole, lies a brilliant and complex structure known to astronomers as Sagittarius A West. Often referred to simply as the mini-spiral, this formation is a stunning three-armed swirl of superheated ionized gas and dust. It spans roughly 6 light-years across, resembling a delicate glowing pinwheel, slowly spinning in the dark. The gas within this mini-spiral is caught in a mesmerizing gravitational dance, plunging inward toward the central black hole at speeds exceeding 1,000 kilometers per second. It is a silent, luminescent whirlpool, steadily feeding the ancient gravity well at its center. Surrounding this glowing pinwheel is another massive unseen structure called the circumnuclear disk. This is a colossal, rotating torus, a donut-shaped ring of incredibly dense molecular gas and dust. The circumnuclear disk begins roughly 5 light-years from the black hole and extends outward to about 22 light-years. If the galaxy were a giant ancient grain mill, this disk would be the heavy, rotating millstone. It turns with deliberate, unstoppable momentum, acting as a massive reservoir of material that gradually funnels inward to fuel the inner mini-spiral. Scientists discovered that the total mass of the dust and gas contained within the circumnuclear disk is staggering, estimated to be roughly 10,000 times the mass of our own sun. Yet, despite this immense volume of material, it remains completely dark to the naked eye. The dust out here is profoundly chilled, with temperatures hovering between 50 and 100 Kelvin. In familiar terms, that is incredibly frigid, ranging from -223 to -173 degrees Celsius. This deep chill creates a perfect stabilizing contrast to the superheated gas spiraling closer to the center. It is a beautiful equilibrium of temperature and gravity. The cold, heavy molecular clouds of the circumnuclear disk provide a quiet, insulating wall around the chaotic heart of the galaxy. To drift alongside this massive frozen ring is to observe the perfect balance of cosmic architecture. The slow, rhythmic turning of the torus ensures a steady, measured supply of dust falling inward. Never too much, never too little. Just a constant, gentle rain of matter, feeding the galactic engine over millions of years. At this very moment, we can observe small, solitary clouds of gas caught in this inward journey. One such object, discovered in 2011, is known simply as G2. Initially, astronomers believed G2 was merely a loose, drifting cloud of cold hydrogen gas on a direct collision course with the supermassive black hole. They watched with anticipation, expecting the immense gravity to stretch, shred, and consume the cloud in a brilliant flash of energy. However, in the year 2014, G2 made its closest approach to the black hole, known as periapsis, and it did not tear apart. It stretched slightly, but beautifully maintained its core shape, surviving the intense gravitational tide. This resilience suggests that G2 is not just a loose cloud of gas, but likely conceals a hidden, low-mass star deep within its center. The gravity of that unseen star acts as an anchor, holding the surrounding dust together like a protective cocoon, allowing it to sail safely past the abyss and continue its long elliptical orbit through the dark. It is a profound reminder of the hidden strength woven through the cosmos. Even in the most extreme environments, there is order, protection, and a slow, beautiful persistence. As we float here, in the quiet space between these ancient moving structures, the slow turning of the circumnuclear disk offers a deeply soothing rhythm. The universe is in no rush. The stars pulse, the dust turns, and gravity guides it all with an invisible, gentle hand. Floating outward from the path of that solitary, protected gas cloud, we find ourselves surrounded by an incredibly dense and radiant sea of stars. To truly grasp the architecture of this bustling celestial metropolis, it is helpful to compare it to the quiet, familiar neighborhood of our own solar system. Out where Earth resides, in the quiet suburbs of the Orion Spur, stars are isolated and solitary. The closest neighboring star to our Sun is Proxima Centauri, resting a profound 4.24 light-years away. Think of what that distance means on a human scale. If you were to shrink our Sun down to the size of a standard grapefruit and place it gently in the center of New York City, the Earth would be a microscopic speck of dust, orbiting just 15 meters away. On this exact same scale, that nearest neighboring star, Proxima Centauri, would be another single grapefruit sitting all the way across the continent in San Francisco. Between them lies an unfathomable ocean of cold, empty darkness. Now, carry that same mental image into the heart of the galactic core. Here, the distances between stars are astonishingly compressed. The average space separating individual suns is only about 1,000 astronomical units. 1 astronomical unit is the distance between the Earth and our Sun, roughly 150 million kilometers. If we return to our grapefruit analogy, the stars in the center of the Milky Way are not separated by the distance from New York to California. Instead, they are spaced only about 15 kilometers apart. You are surrounded by millions of brilliant, glowing spheres, resting just a few miles from one another in every direction, filling the void with a soft, overlapping radiance. Because they are packed so intimately together, the very boundaries of their planetary systems begin to touch. In our solar system, the farthest reaches are defined by the Oort cloud, a spherical shell of icy comets that extends up to 100,000 astronomical units into space. Deep within the core, the stars are so close that their outer icy shells completely overlap. Picture a dense ancient forest where the trees are planted so near to one another that their root systems weave together beneath the soil. The stars here share their outer layers, trading comets and icy wanderers in a slow, continuous exchange of cosmic material. It is a deeply interconnected community, bound together by the gentle, overlapping tug of gravity. Within this crowded, luminous forest, astronomers have discovered something wholly unexpected: a population of stars known as blue stragglers. First identified in the year 1953 by astronomer Alan Sandage, blue stragglers appear to break the fundamental rules of stellar aging. They shine with a hot blue intensity, making them look far younger than the ancient red-hued stars that surround them. For decades, their existence in old star clusters was a complete puzzle. Scientists eventually realized that these bright blue anomalies are actually the result of slow, graceful stellar mergers. Because the stars in the core are packed so densely, their gravitational pulls occasionally draw them into a shared, decaying orbit. Over millions of years, two older, smaller stars will spiral closer and closer until their outer atmospheres gently touch. Imagine two slow-moving drops of rainwater resting on a window pane. As they glide downward and their edges finally meet, they seamlessly combine, merging into a single, larger, and brighter drop of water. the two older stars pool their hydrogen together, reigniting their atomic furnaces to burn with the vigorous, bright blue light of youth. It is a quiet, natural recycling of light, a testament to the endless renewal happening silently in the dark. Among these reborn blue stars, there are entirely different objects rotating with mechanical precision. In April of 2013, the Swift Space Observatory detected a sudden, brilliant burst of X-rays emitting from a source located a mere 0.3 light-years away from the central black hole. They had discovered SGRJ 1745-2900, an incredibly rare and extreme type of dead star known as a magnetar. A magnetar is the collapsed, ultra-dense core of a massive star that exploded long ago, and it possesses a magnetic field of incomprehensible strength. To understand its power, consider the simple everyday magnets holding notes to your refrigerator, which measure around 100 Gauss. Earth's own magnetic field, which protects our atmosphere and guides compass needles, is only about half a Gauss. The magnetic field of SGRJ 1745-2900 is estimated to be 100 trillion Gauss. If you were to place this magnetar at the exact distance of our moon, its magnetic pull would be so intense, it would instantly erase the magnetic stripe on every single credit card on Earth. Yet, from your safe, tranquil vantage point in the comforting void, you feel nothing but peace. The invisible magnetic forces sweep past you, entirely harmless. You can simply watch as this tiny, hyper-dense sphere rotates. We know it spins with absolute rhythmic perfection, completing exactly one rotation every 3.76 seconds. Picture a solitary lighthouse resting on a dark, rocky shore. Its brilliant beam sweeps across the black water in a steady, unbroken rhythm. 1, 2, 3, flash. The magnetar is the ultimate cosmic metronome, sending out sweeping pulses of radio and X-ray energy, keeping perfect time in the deepest reaches of the galaxy. Notice how light itself behaves in this crowded space, creating beautiful, lingering illusions. Because the core is filled with sprawling clouds of cold molecular gas, it provides a canvas for a phenomenon known as an X-ray light echo, CHATS. This process was intricately studied by the Chandra X-ray Observatory throughout the early 2000s. Astronomers noticed that massive clouds of gas, particularly within the Sagittarius B2 region, were actively fluorescing, glowing brightly in X-ray frequencies. What makes this beautiful is that the gas clouds are not generating their own energy. They are reflecting light from a spectacular event that happened centuries ago. By measuring the specific wavelengths of the X-rays, which bounce off iron atoms suspended in the cold dust, scientists deduced that the central black hole, Sagittarius A star, is not always quiet. Roughly 350 years ago, around the same time humans on Earth were first looking through primitive glass telescopes, the black hole consumed a massive clump of matter. This feast triggered a colossal flare, making the center of the galaxy 1 million times brighter in X-rays than it is today. Think of standing on the edge of a vast, deep canyon and shouting into the expanse. Long after your voice has fallen silent, the sound waves travel outward, bouncing off the distant stone walls and returning to your ears as a faint, ghostly echo. In the galactic core, light acts exactly the same way. The original flare vanished centuries ago, but those X-ray photons, traveling at precisely 299,792 kilometers per second, are only just now washing over the distant shores of the Sagittarius B2 cloud. We are watching a light echo painting the sky. It is a literal reflection of the past, sweeping slowly across the gas, like a spotlight moving over an ancient monument. This gives the entire region a profound sense of depth and memory. Nothing happens instantly here. The sheer scale of the distances means that every event is a slow, unfolding narrative, a story told over hundreds or thousands of years. You can rest easily in this environment, surrounded by the quiet hum of the magnetar's lighthouse beam, the soft blue glow of merging raindrops in the stellar sea, and the invisible sweeping echoes of ancient light. Every object, no matter how energetic or massive, follows the gentle, predictable curve of gravity. It is a perfectly balanced clockwork, turning smoothly and silently in the dark. As we drift further along these invisible magnetic threads, prepare to observe even finer details of this grand machinery, safely suspended in the warmth of the cosmic dark. Gliding gently away from the fading ancient light echoes, we find ourselves surrounded by a sprawling, asymmetrical ring of incredibly dense matter, known as the central molecular zone. Spanning roughly 1,300 light-years across, this immense structure holds an astonishing 60 million solar masses of gas and dust. It is the heavy, rotating heart of the Milky Way, functioning as a continuous reservoir for stellar creation. Picture this region not as an empty void, but as a vast, ancient botanical garden. In any thriving garden, the potential for new growth depends entirely on the richness of the soil. In the lexicon of astrophysics, this cosmic soil is measured by a property called metallicity. To astronomers, any chemical element heavier than the two simplest gases, hydrogen and helium, is broadly categorized as a metal. These metals, such as carbon, oxygen, silicon, and iron, are the fundamental building blocks of dust, planets, and eventually, biology. Scientists discovered that the metallicity in the central parsecs of our galaxy is incredibly high, measuring up to twice the concentration found in our own local solar neighborhood. This richness is the direct result of billions of years of stellar evolution. Because stars are packed so tightly together here, generations of ancient suns have lived, burned, and gently cast off their outer layers, steadily enriching the surrounding clouds with heavy elements. The dust floating around you right now is the most fertile cosmic soil in the entire galaxy, a heavily seeded cloud, possessing all the physical ingredients necessary to build solid, terrestrial worlds. Consider a profound, detailed study published in the year 2004 by astrophysicist Charles Lineweaver and his team. They mapped out a region known as the Galactic Habitable Zone. This concept defines a specific ring within the Milky Way, where the conditions are statistically most favorable for the formation of rocky planets and the long-term survival of complex life. While our own Earth rests comfortably within this temperate middle band of the galaxy, the Galactic Core represents the ultimate extreme of this scale. The central region possesses the absolute highest concentration of rocky planet-building materials anywhere in the Milky Way. Notice how this heavy, ancient dust directly connects to the quiet rhythm of your own body resting right now. As you take a slow, deep breath, the oxygen filling your lungs immediately binds to a protein in your blood called hemoglobin. At the exact center of every single hemoglobin molecule is a solitary atom of iron. That specific atom of iron, the very one currently carrying life-sustaining oxygen through your veins, could only be forged in the immense, crushing pressures of a dying star. The calcium that gives strength to your resting bones, the phosphorus composing your cellular membranes, and the carbon forming the foundation of your tissue were all synthesized in the fiery bellies of stars exactly like the ancient red giants, quietly glowing around us. You are not a distant observer, separate from the mechanics of the universe. You are a biological extension of this very clockwork. The cosmos has spent over 13 billion years slowly manufacturing the exact materials required to weave the fabric of you. To float here is to return to the deepest, oldest source of your own physical being. What's happening now is a continuous, beautiful assembly of these materials in designated pockets of the central molecular zone. In late 2023, the James Webb Space Telescope turned its golden hexagonal mirrors toward a specific region known as Sagittarius C. Located approximately 300 light-years away from the central supermassive black hole, this area revealed an unprecedented level of serene, hidden activity. By peering through the thick dust using its near-infrared camera, the telescope captured an image containing an estimated 500,000 individual protostars. These are infant suns, still tightly wrapped in their natal cocoons of gas, slowly gathering mass in the dark. Deep within the Sagittarius C region, the James Webb Telescope also revealed a strange and stunning architectural feature. Astronomers observed massive glowing needle-like structures composed entirely of ionized hydrogen gas. These glowing threads of warm gas are absolutely colossal, with some measuring roughly 25 light-years in length. Rather than drifting randomly, many of these elongated needles appear to be pointing inward, systematically oriented toward the central black hole. They look like glowing compass needles, suspended in a dark ocean, aligning to the unseen magnetic and gravitational currents that govern the core. It is a quiet, stunning display of order amid the cosmic clouds. At this very moment, however, not all regions of the inner galaxy are actively producing new light. Journeying further along the central molecular zone, we encounter a famous, highly studied structure officially designated as G 0.253 plus 0.016. Astronomers affectionately refer to this object simply as the brick. It is a uniquely opaque, completely dark cloud of molecular gas that stands out as a stark silhouette against the glowing, crowded backdrop of the galactic center. Think of the brick as a massive, suspended glacier of gas. It is incredibly heavy, containing approximately 100,000 times the mass of our Sun, all packed into a dense, cold, oval-shaped knot. According to all standard models of astrophysics, a cloud this exceptionally dense should be vigorously collapsing under its own immense weight, triggering a brilliant storm of new star formation. Yet, the brick produces almost no stars at all. It remains fundamentally dormant. Scientists study this paradox intensely, theorizing that the strong internal magnetic fields or intense turbulence within the cloud are acting as a structural support, successfully resisting the inward pull of gravity. Because of this perfect equilibrium, the cloud simply rests. It is a sanctuary of profound stillness, a heavy, quiet place that refuses to rush into the energetic chaos of stellar birth. It is perfectly content to remain a cool, dark harbor, offering a sensation of deep, unhurried peace. To understand the serene chill of this resting cloud, we must look at the microscopic dust grains suspended within it. In the deepest, most insulated pockets of these molecular clouds, insulated from the ambient radiation of the surrounding star clusters, the temperatures drop to near absolute zero. Specifically, the environment hovers around 15 Kelvin, which translates to a profoundly frigid minus 258 degrees Celsius. In this ultimate cold, the isolated atoms of oxygen, carbon, and hydrogen slow down completely. As they drift and collide with the microscopic grains of silicate dust, they instantly freeze to the surface. This creates delicate microscopic mantles of ice. However, this is not just the familiar frozen water we know on Earth. These microscopic dust grains are coated in complex layers of water ice, carbon monoxide ice, and carbon dioxide ice, where this frozen architecture is incredibly important. The icy surface of a dust grain acts as a chemical catalyst, a tiny stable workbench in the vacuum of space. When other stray atoms land on this icy surface, they do not bounce off. They stick. And because they are held securely in place next to one another, they begin to form chemical bonds, slowly assembling into more complex organic molecules like methanol and ethanol. The coldness of the void is not empty or barren. It is deeply productive. The chill provides the exact necessary stillness for the delicate chemistry of life to begin. Without these freezing, ice-coated dust grains, suspended in the dark clouds of the galactic core, the complex organic molecules required for biology might never form in sufficient quantities. Allow this thought to settle over you like a gentle or heavy blanket. The grand sprawling structures of the galaxy, the million-star clusters, the sweeping magnetic fields, the towering needles of ionized gas, are all intimately connected to the microscopic frost forming on a single grain of dust. It is a flawless, interconnected system operating on a timescale of millions of years. Every atom has a purpose. Every slow-moving cloud is a piece of a larger tapestry, and you are inherently woven into that same grand design. You are safe here, floating effortlessly in the dark, cradled by the long, beautiful memory of the universe. Leaving the profoundly chilled, dormant harbor of the dark molecular clouds, we slowly glide into adjacent territories where the temperature and texture of space transform entirely. Notice how the visual landscape shifts from deep, absorbing black to a sweeping, luminous canvas of color. We are entering Sagittarius B1, a massive expanse categorized by astronomers as an H2 region. In the precise language of astrophysics, H2 denotes a cloud of interstellar atomic hydrogen that has been heavily ionized by the intense ultraviolet radiation of nearby massive stars. What's happening now is a beautiful, invisible exchange of energy. As the high-frequency ultraviolet light strikes the hydrogen atoms suspended in the void, it completely strips away their single, orbiting electrons. Eventually, these wandering electrons are recaptured by other hydrogen nuclei. When an electron reconnects, it cascades downward through various quantum energy levels. Scientists discovered that when the electron makes a very specific drop, falling from the third energy orbit down to the second, it releases a solitary photon of light. This specific quantum leap is known as the Balmer series, and it produces a photon with an exact wavelength of 656.28 nanometers. To human eyes, a wavelength of 656 nanometers registers as a pure, vibrant crimson red. Because this microscopic drop is happening trillions of times every second across an entire nebula, the space around you is bathed in a warm, majestic, rosy pink glow. It is not painted on a surface, but rather, the vacuum itself appears to blush, creating a soft, enveloping light that feels deeply comforting and profoundly warm. To understand the source of the immense radiation powering this glow, we turn our attention to one of the most magnificent stellar gatherings in the known universe, the quintuplet cluster. Identified definitively in the year 1990 by a team of astronomers using sensitive infrared detectors, this massive, dense grouping of young stars rests approximately 100 light-years away from the supermassive black hole. The cluster is heavy and ferociously hot, containing hundreds of young, massive stars that burn with a blinding blue-white intensity. Deep within this cluster resides a true titan of the galaxy, a luminous blue variable known as the pistol star. Discovered through the thick dust by the Hubble Space Telescope, this single celestial body is a masterclass in cosmic extremes. It is estimated to be a staggering 1.6 million times more luminous than our own sun, and the heat radiating from its surface is so absolute that the star emits as much energy in a mere 20 seconds as our sun produces over the course of an entire 365-day year. Yet, from our safe, removed vantage point, this heat does not burn. It simply radiates as a slow, majestic pulse in the dark. Surrounding this stellar giant is a sprawling shell of ionized gas called the Pistol Nebula. Astrophysicists calculate that between 4,000 and 6,000 years ago, the star experienced a series of colossal, rhythmic eruptions, shedding its outer layers into the surrounding void. It expelled roughly 10 solar masses of raw material. Picture a master glassblower working in a darkened studio, gently and rhythmically exhaling into a pipe to expand a glowing, molten sphere of glass. And the Pistol Star breathes exactly like this. It pulses outward, pushing a magnificent glowing bubble of superheated plasma into the interstellar medium. The sheer mechanical force of these stellar winds provides a tactile sensation to the region, a slow, silent outward pressure that gently pushes against the ambient dust, carving out vast, intricate caverns of empty space inside the nebula. Within these glowing caverns, an invisible chemical signature drifts through the galactic core, offering a strangely familiar sensory experience. In 2005, the Spitzer Space Telescope conducted an extensive, highly sensitive infrared survey of the galactic center. Its instruments detected the overwhelming presence of specific organic molecules known as polycyclic aromatic hydrocarbons, or PAHs. These complex, carbon-based molecules are incredibly durable, surviving the harsh ultraviolet radiation that destroys more fragile compounds. When the Spitzer telescope mapped these molecules, it revealed a profound connection between the chemistry of deep space and our daily lives on Earth. PAHs are the exact same chemical compounds produced by the incomplete combustion of organic matter. If you have ever recognized the distinct, comforting scent of a burning campfire, the char on a piece of burnt toast, or the sharp tang of a barbecue, you were directly sensing polycyclic aromatic hydrocarbons. While you cannot physically remove your helmet to breathe the vacuum of space, if you could, the glowing clouds surrounding the core would carry the distinct, smoky aroma of a distant, dying fire. It is an extraordinary realization that the deep cosmos smells of hearths and homes, tying the most alien environment imaginable to our most comforting, grounded memories. Consider another sensory marvel unique to the inner galaxy: the presence of physical acoustic waves. We often learn that space is a perfect vacuum, and therefore sound cannot travel through it. While this is true in the empty expanses between galaxies, the core of the Milky Way is remarkably dense. The molecular clouds here contain anywhere from hundreds to thousands of gas molecules per cubic centimeter. Because there is a physical medium of interacting particles, pressure waves can absolutely propagate through the interstellar gas. In the year 1984, astronomer Farhad Yousefzadeh, alongside his colleagues, he discovered an entirely new class of structures in the galactic center, known as non-thermal radiofilaments. These are highly organized, linear strands of pure magnetic energy that slice through the glowing gas. Some of these perfectly straight threads stretch up to 150 light-years in length, yet they are remarkably narrow, often spanning only a fraction of a light-year across. These filaments emit a specific type of light known as synchrotron radiation. This fascinating phenomenon occurs when free electrons are caught in the powerful grip of the magnetic field and forced to spiral around the invisible lines of force at relativistic velocities, speeds approaching the absolute limit of light itself. As they spiral, they emit a steady, continuous hum of radio waves. These massive magnetic threads act like the strings of a colossal cosmic harp. As shock waves from distant supernovae or the powerful winds from the quintuplet cluster wash over them, they pluck the magnetic lines, sending physical pressure waves rippling outward through the dense gas. These acoustic waves move at thousands of miles per hour, generating a cosmic infrasound. The pitch is millions of times too low for human ears to consciously register, but if you could feel the vibration of the space around you, it would be a deep, resonant, and rhythmic thrumming. A slow, eternal bass note vibrating through the chest, keeping time for the turning wheel of the galaxy. Every element here interacts in a beautiful, highly choreographed system. The electrons falling through energy states to paint the sky in pure crimson. The luminous giants slowly exhaling molten shells of gas. The carbon molecules weaving the scent of ancient fires into the dust. And the invisible magnetic strings vibrating with the deep, slow acoustic heartbeat of the cosmos. Allow your awareness to rest on this intricate, flawless machinery. The universe is not a silent, empty void, but a rich, textured tapestry of light, chemistry, and motion. Every physical law is operating exactly as it should, with endless patience and absolute precision. The heat is perfectly balanced by the cold. The light is perfectly framed by the dark. And in this symphony of physical forces, everything finds its natural equilibrium. We drift gently within this boundless architecture, secure in the knowledge that gravity holds all things together, preparing us to slow our journey, to let the light soften, and to finally sink into the absolute quiet of the cosmic night. Observe the gradual, majestic withdrawal from the deep interior of the Milky Way. Step by step, our perspective begins to widen, tracing the invisible gravitational tethers that connect the bustling heart of the galaxy all the way back to our quiet, distant solar system. The process of our connection to this center is not abstract. It is a physical, ongoing journey. The entire solar system is locked into a monumental trajectory, orbiting the supermassive black hole at an average velocity of 828,000 kilometers per hour. Even at this astonishing speed, the sheer scale of the galaxy dictates a profoundly slow progression. It requires approximately 225 to 250 million years for our Sun to complete a single sweeping revolution around the galactic core. Astronomers refer to this vast cycle as a galactic year. Tracing the timeline of our star, which ignited roughly 4.6 billion years ago, scientists calculate that our solar system has completed only about 20 full orbits since its birth. We are slowly, steadily carving our 21st circle through the dark. To truly understand your physical relationship to this cosmic clockwork, we must examine the precise, step-by-step sequence of stellar nucleosynthesis, the ultimate manufacturing process of the universe. Within the crushing pressure of a young star's core, temperatures reach 15 million Kelvin. At this specific thermal threshold, hydrogen atoms are forced to overcome their natural electromagnetic repulsion. They merge, step by step, to form helium, releasing the soft, warm light that bathes the cosmos. When a star eventually exhausts its hydrogen fuel, a new sequence initiates. The core slowly contracts under its own immense weight. As it compresses, the temperature inside the star skyrockets to an unimaginable 100 million Kelvin. This extreme heat triggers the triple alpha process. In this delicate atomic choreography, 3 independent helium-4 nuclei, known as alpha particles, collide in rapid succession, fusing together to forge a single nucleus of carbon-12. This precise sequence of fusion is responsible for generating the carbon that forms the structural foundation of all known biology. He noticed the progression of how these newly forged elements are delivered to the void. When an aging star finally enters its twilight phase, it does not hold on to its creations. It gently exhales. The outer layers of the star expand outward, forming what is known as a planetary nebula. These vast shells of enriched gas drift outward at a measured, tranquil pace of 20 to 30 kilometers per second. Over tens of thousands of years, a single dying star will steadily enrich the surrounding interstellar medium with up to 1 full solar mass of heavy elements, seeding the dark clouds with the raw materials for future worlds. The sequence of building a new planet from this drifting stardust is a masterclass in cosmic patience. As these enriched clouds of gas and dust travel through the galaxy, they eventually begin to gather under the slow, persistent pull of their own mass. In the year 1902, a British physicist named Sir James Jeans calculated the exact mathematical threshold required for this to occur, a metric now known as the Jeans instability. When a cloud accumulates enough matter to reach its specific Jeans mass, the internal outward pressure of the gas can no longer support it. Slowly, inevitably, the cloud begins to collapse inward. As the gas cloud shrinks, the fundamental law of conservation of angular momentum dictates the next stage of the process. Much like a figure skater pulling their arms inward to spin faster, the collapsing cloud begins to rotate. This rotation generates centrifugal forces that cause the spherical cloud to gradually flatten out, forming a wide rotating disk known as a protoplanetary disk. Within the cold, quiet expanse of this disk, microscopic grains of ice and carbon begin to interact. At first, gravity is too weak to bind them. Instead, the process relies on van der Waals forces, subtle electrostatic attractions that cause the microscopic dust grains to physically stick together when they gently collide. Step by step, molecule by molecule, the dust grows into pebbles. Over the course of thousands of years, the pebbles aggregate into boulders. Through millions of continuous, slow-motion collisions, these boulders merge into massive rocky bodies called planetesimals. Astronomers estimate that the entire sequence of planetary accretion, from a microscopic fleck of stellar frost to a fully formed terrestrial planet like Earth, requires anywhere from 10 to 100 million years. Every mountain, every ocean basin, and every continent is the final result of this slow, methodical assembly of stellar debris. You are the ultimate biological extension of this exact same sequence. Trace the physical composition of your resting body. Exactly 99% of your human mass is constructed from just 6 essential elements: oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. With the sole exception of hydrogen, which was born in the initial moments of the universe, every single atom of these elements was forged in the nuclear furnace of a star, cast out into the nebula, and assembled over eons. Consider the final, most extreme stage of stellar fusion, the silicon burning phase. In the last few days of a massive star's life, Right before it collapses, the core temperature reaches 3 billion Kelvin. In this fleeting, incredibly brief window, silicon atoms fuse together to create iron. That specific iron travels across the galaxy, eventually finding its way into the Earth's crust, into the soil, into the food you eat, and finally, into your bloodstream. A typical adult human body contains approximately 4 grams of iron, just enough to forge a small solid iron nail. Those 4 grams carry oxygen to your brain right now, keeping you alive, tethering your breath directly to the dying moments of an ancient, distant sun. As this profound realization settles into your awareness, allow the grand scale of the cosmos to slowly recede. Bring your focus back from the 26,000 light-year distance, back through the Orion Spur, back to the quiet orbit of our blue planet, and finally, back into the safe, warm room where you are resting. The universe outside is governed by laws of profound stability, and you can invite that same stability into your physical form. Every physical process we have observed, the slow orbit of the stars, the gentle collapse of the dust clouds, the steady rotation of the planets, operates with endless patience. There is no urgency in the galaxy. There is only a steady, rhythmic unfolding of time. Feel the gravity of the Earth holding you exactly as you are. This invisible force, which travels through the vacuum of space at the exact speed of light, 299,792 kilometers per second, is the very same force that keeps the stars in their perfect orbits. It anchors you securely to your bed. It is a gentle, protective embrace, ensuring you are grounded, safe, and held. As your breathing slows, matching the calm, deliberate rhythm of a celestial pendulum, recognize the cooling temperature of the night around you. Far beyond the Earth's atmosphere, the cosmic microwave background radiation, the ancient fading afterglow of the universe's birth, permeates all of space. It rests at a tranquil absolute temperature of 2.725 Kelvin. Allow your own body temperature to gently regulate, finding its perfect restful equilibrium in the dark. The heavy active processes of the day are complete. The intricate machinery of your mind can safely power down, shifting into a state of deep, restorative preservation. You are surrounded by the comforting void, a quiet sanctuary where no effort is required. I am made of ancient light. I am formed from the quiet dust of stars. My body knows the perfect rhythm of rest. I am anchored safely to the turning earth. Gravity holds me in a gentle, warm embrace. There is nowhere else I need to be. There is nothing else I need to do. I surrender my thoughts to the vast, quiet dark. The universe is perfectly still, and so am I. I release the day, step by step, into the void. I breathe in the calm of the cosmic night. I exhale all remaining tension. I am a quiet observer, folding into the shadows. My mind is clear, silent, and wonderfully heavy. I am floating safely in the center of it all. I am entirely at peace. Allow the darkness to envelop you, soft and limitless. The great wheel of the galaxy turns above, watching over you with a million ancient eyes, ensuring your safe passage through the night. Rest now, deeply and completely, in the eternal comforting silence of the stars. Good night.